All right, so today we are going to talk about, we're going to learn about one of Earth's natural processes by reading about earthquakes. Now we're going to just kind of look through it and skim it and notice some things as I annotate. So if you have your book, and get some pens or pencils ready so you can do it along with me. But right away I see that the author has organized it by heading. So if I see what causes earthquakes, that means this paragraph is going to tell me what causes earthquakes. And then my other heading is measuring quakes. So that means that one's going to tell me about how to measure it. And then the last thing they're going to tell me is Earth's changing surface. So right away I know the author's organized it not into chapters but by heading. So that's going to help me out. The next thing that I notice is that I've got some pictures down here. So if I look at, I notice this, and I notice this. So it says most earthquakes occur along the boundaries of the Earth's tectonic plates. So I'm looking here. These white lines are the plates of the Earth. These are our tectonic plates. And then this is an example of how those actual lines move. So this is one piece of land is going this way and one piece of land is going this way. I think this is going to help me understand one of the paragraphs. The other thing that I notice here is I recognize this. This looks like from our science, and we're talking about sound waves. So a seismograph with a drum and pen. So this must be a picture of something that we're going to read about is the seismograph. Because I'm really not quite sure what that is, but it's a picture of it, and it looks like those look like those sound waves. Remember that slinky and stuff? And then these are the picture of the Himalayas. So I'm wondering how the Himalayas have to do with the earthquakes. Oh, and look, there's a little person right there. All right, so now that I've kind of looked it over and I've seen some of the things the author has done, I know that this is a nonfiction, so I'm going to be looking for key details as I go along. There might be some wows, and I'm going to be using my different symbols, and you can use your own, and I might be jotting some notes down here on the side. Just so you know, these are called headings, or sometimes they're called subheadings. Just so you know what the real term for that is. Okay, so every day an average of 50 earthquakes are detected on the Earth's surface. I'm going to go, wow, I did not realize that was every day. Why do some earthquakes cause major destruction while others go by almost unnoticed? The answer is in the amount of energy they release. Okay, so the author is actually starting us off with a question. This is the question they're going to answer for us. It says, why do some earthquakes cause major, because if there's 50, destruction, while others go by unnoticed? And then this one, it says the answer is in the amount of energy they release. I'm not quite sure what that means, so I'm going to put some questions mean. So the energy they release. Well, how do they do the energy? How do they do it? I'm going to put how. All right. So now we're on what causes earthquakes. So now we're getting into the part that what causes our earthquakes. An earthquake is a sudden movement or shift of the Earth's crust. Okay. So that doesn't tell me what causes it, but that tells me what it is. So an earthquake, I'm going to underline that because that tells me exactly what it is. It's a sudden movement or shift of the Earth's crust. It doesn't tell me what causes it, it just tells me what it is. This thin outer layer is made up of many interlocking pieces called tectonic plates. Okay, so tectonic plates is interlocking pieces, many interlocking pieces of the outer layer. Okay, so that's what these are right here. So I'm going to put my arrow down here. These are the plates. These plates float on a layer of hot molten rock and move slowly as fingernails grow. Okay, so that I think is trying to tell me how slow it is. So that means when these plates aren't moving fast, they're moving slowly. And I didn't know that they floated on a layer. So I'm going to put like a little wow here. I didn't know that they floated. As they move, they rub against one another, building up stored energy and pressure. Okay, so I think that goes to this picture right here. This is showing us moving. Now, kind of think about they rub against each other, building up stored energy. Kind of when we rub our hands for our mindful minute, we start to feel warmth. And so that's kind of part what the earth does too. So they're building pressure and that heat as they're rubbing next to each other. So it's just, or if they're moving closer, or if they're rubbing to each, that's caused that pressure. When these plates shift or collide at their boundaries, an earthquake happens. Okay, so these parts where these white lines are where most of the earthquakes. So shift means shift, they're moving this way. Collide means the two plates are coming together and go this way. And sometimes you get an earthquake when those plates go out. So they can have an earthquake if they go this way. They can have an earthquake if they go out. And then they can have an earthquake if they bump into each other. Okay, so that's what causes earthquakes, when the plates collide or shift. So actually I'm going to choose a different color and put a big star. So this is when the plates shift or collide at their boundaries, an earthquake happens. Earth's surface rumbles and shakes as the energy released. Okay, so that means when that energy is released, when they move, that's what we feel. We feel the rumble and the shakes. And that's the energy being released. So all that pressure building up and it's released. Think of a teapot. When it gets really hot and all that energy comes out, it's that loud whistle. All right, so now let's go to measuring quakes. Now we know what causes them. Now let's see what measures them. Scientists can measure the strength or magnitude of an earthquake with an instrument called a seismograph. Okay. So the seismograph, that one is measuring the strength or magnitude. So that's how strong it is. So that's what so this seismograph is measuring how strong that energy release is. In one of types of seismographs, seismic waves cause a drum to vibrate as a weighted pen records the vibrations. Ooh, that's part of our science, remember? Those waves. So this is the vibration. So if you see it go, the higher it goes, the stronger the earthquake is. The longer the lines, the greater the energy released by the earthquake. So if it's greater energy, that means stronger earthquake. So if it's greater, that means it's a stronger earthquake. And the seismograph is the instrument that measures that. It's one of the instruments that measure that. All right, Earth's changing surfaces. The movement of the Earth's tectonic plates reshapes the Earth's landscapes. Okay, so the movement of this reshapes the Earth's landscapes, building landforms such as mountains and valleys and other land features. Plates move apart. Okay, so as the plates move apart, the valleys, rivers, and even oceans can form. Okay, so I'm going to make my little notes here. As the plates move apart, that's when I have the valley. So I have the mountain and I have the valley. And it can also be the rivers or ocean? I like pictures, so I'm going to do pictures. So as these plates are moving, that's why we get changing. So I'm wondering if that's why we have it down here. This is some evidence of the plates moving. You see the river down here? And then this is the valley. So the valley is right here, and then the river goes through here. The Himalayan mountain range in Asia, for example, was formed when the Indo-Australian and Eurasian plates came together. Oh, so apparently they have names. So this one, so the mountains are when they come together. So that means this plate is moving this way, this plate is moving this way, and then when they collide, the earth comes up and we start to have a mountain. So this mountain is formed by the two plates going together. The plates collided and pushed upward slowly. So this is not a fast process. Slowly forming the mighty mountain range over the last 10 million years. Wow, that's how slow, 10 million years. So if I go back, it was the Indo-Australian and the Eurasian plates. So let's look at our map. So here's the Eurasian and the Indo-Australian, so right here. So right through here, and you can see the mountains. So when these two plates collided, that's where those mountains, so that plate pushed here, and that plate pushed here, and those mountains are what were formed. So using that map actually helps us see where that happened too. So as they float along slowly, they crush into each other, and the land is pushed up, and we have mountains. So some of the mountains we see are from volcanic activity, but some are also from earthquakes and the plates moving and pushing together. All right, so with this one, we are going to answer some questions in the Google Doc below. The questions that we are going to answer is, what is an earthquake? Where do earthquakes happen? And how do earthquakes reshape the earth? Use your title headings to help you answer those questions. The where do they happen, you might have to look a little bit. I'm going to give you a clue. This is where earthquakes happen. I'm going to give you a clue, so if you watch the video, you find one of your answers.